All right, video 2 on slope. Today we're going to show you how to find the slope by measuring the rise over the run. Now, pardon my handwriting. I'm trying to do this on just a little whiteboard here at home, so it's not going to be perfect. I've got the same line here twice. I've done the same grid, the same representation, two different ways. First of all, the first video, I just showed you kind of an introduction to slope. And that slope can be, it can go uphill. I use this pencil. The slope can go in, it can increase, it can decrease, it can be vertical, it can be horizontal. And we need to figure out a way to label that so everyone throughout the math world knows what we're talking about when we talk about the steepness of a line or the slope of a line. The most common way, the first one we're going to talk about today, is just measuring by the rise over the run. It is a ratio of the change in the rise, how much it goes up, versus how much the line goes across. There's three ways you can see it written. We first teach it, the rise over the run. It's a fraction, it is a ratio. It's also, though, that's just the kind of the way we look at it, rise over run. But what that is the change in the y values of the graph divided by the change in the x values of the graph. Another way to write that is kind of a shortcut, the Greek letter delta, I think, I'm not sure, but they call it delta y, or the change in the y over the change in the x. These three are the same thing. It's just a way to measure the steepness of a line. So let's talk about the first one up here. I drew the grid, not very well, I just kind of eyeballed it, but I drew a grid here for the graph, and I have a line. It's a straight line. There's an infinite number of points on the line. I always, would ask you kids how many points are here, and they always say 4, but no, there's an infinite number of points. I'm just showing you 4 of them. So we want to figure out the slope of this line. All right, the slope of the line. I also had it down here, a same ratio. I'll talk about this in a second. It's the same thing, just written, not showing all the grid lines. So here we have these 4 points as a line. So I want to figure out what is the ratio of the rise to the run. And we can figure that out by making a right triangle that connects the line. This is what I mean by that. So I'm going to start. I can pick any 2 points. It does not matter which points I pick. I'm going to pick the ones that are furthest away just for grins right here. So I'm going to go here. I'm going to make a right triangle from the lower one. I'm going to go up, straight up the axis here to this point. Then I'm going to go directly over to that point. So I make a right triangle like that. Now the line's going like here, so that's what, if you know about right triangles, that's my right triangle. So the line is there, and we just make a right triangle. I could make this triangle above the line. I could make it below the line. I can use any 2 points I want because it's a ratio. And the ratio will be the same regardless of the points I use. And you'll see that as we go through this example. So now once you have that, once you count up and over, make sure it's a straight, you just count how far it is. Obviously, well, kind of obviously, this is the rise up and down. That is the run over and across. You just count. And when I count I go from point up, I will go from here, I go 1, 2, 3, 4, 5. I get 5. And this way, I'm going to get 1, 2, 3. I'm going to pause 1 second here. Little technical difficulties there. I missed a line when I drew it. I didn't want 5. I didn't want that at all. So I missed a line. I had to put it back in there. So where I was, I still make that right triangle. So I'll do it again. I'm going to go up like I did before, and you should see it. I go this way. All right. Now I'm going to count the lines. I'm going to get 6 this time. I left the line out. So I go, as I count from here for the rise, I go 1, 2, 3, 4, 5, 6. It is 6 up that way. So it's 6 units. I know that's hard to see. I apologize about that. It is 6 units up. The rise is 6. Is that better? That is 6. Now I'm going to count the run going this way. That is 1, 2, 3, 4. This is over 4. I counted that wrong again too. One moment. My technical difficulties are really bad right here today. That's why you use real graph paper, not just sketch it. As I count the run right now, it is 1, 2, 3. It's a run of 3. Okay, so the rise is 6, the run is 3. I write that as a ratio, and I don't be confused. Whenever you make this triangle, you often get the rise and run confused. It's the rise is 6, the run is 3. The change in the y value, this is the y-axis, the change in that axis is 6. The change in the x-axis is 3. It is 6 over 3. That, of course, can be simplified to a run or a ratio of 2. So the slope of this line is 2. And this is what that means. This is what slope means. Yes, it's a ratio, rise over run. Slope means, the slope of 2 means, for every time I go 1 over on the x-axis, I go up 2. I go over 1, I go up 2. I go over 1, I go up 2. It's like a staircase. It stays consistent the whole way. So now we can have fractions. Of course we can have fractions that don't come out as whole numbers. But in this case, it is a whole number, which is a great illustration. This is a slope of 2. The rise is 6, run is 3. On this line right here, you can see that is a slope of 2, and it's increasing, it's going up. All right, I'm going to give you one more example here. So I'm going to pause this and redo this. Make you another example. So here's another example without all the bad lines drawn on there. Here's a graph with 2 points. I just put 2 random points on there, but they're in a straight line. Any 2 points make a line. So to figure out the slope, we want to measure the rise over the run. Okay, so I'm going to do the rise. So I'm going to go from here over here. Now this is the run, of course, because it goes across. It's the change this is the change in the x-axis. Okay, this is the run. So I'm going to count 1, 2, 3, 4, 5. This has a run of 5. All right, that's how far it is by counting the scales. Now the rise is going to be 1, 2, 3, 4. I'm going to say it's 4. Okay, it may look different, but that's okay. That's 5 over 4. All right. So the change in the y over the change in the x. The rise is 4. The run is 5. That is a slope of 4/5. Okay, now is this 4/5? It's -4/5. See how the line is going down? The line is decreasing as it goes down. So it's a -4/5, and this is one way that you can see that. See that on the graph, the x value, every time you go this way, you are increasing. On the y value, when you're going up, you are increasing. So when I count the run this way, that's a +5. I'm increasing. But when I went down, I'm going down on the run. So actually, when I write the rise over run, really, the way I counted it, it's a -4 over 5, which is a negative number. Now, one of my teachers a friend of mine showed me this at Valley View. I think it's Mr. Clinch. When you can write this little square above or below the line, it doesn't matter. Look what happens if you draw the right triangle. If I do the triangle below the line, like here, I'm going to get the same thing. When I measure the rise, I'm going to have negative. It's going to go down 4. 1, 2, 3, 4. When I do the run, it's going to be 5. 1, 2, 3, 4, 5. Casey told me that, if we have your kids always write the triangle below the line, it just so happens the rise is always over the run. See, so the fraction gets more. It's not as, you can kind of keep track of it that way. It's still the same thing. It's -4 over 5, also -4/5. So we get confused, and even doing this little video, when I drew it this way, I have to think, what's the rise, what's the run? Because it's the rise over the run. So if you drew the line under, you get the same either way, but you can kind of keep track. That's the rise and the run, so the fraction will look like this. When you do it this way, you just got to keep thinking, well, it could be different. Let me pause here. I'll give you 2 more examples of measuring the rise from the run. Okay, this is way longer than I wanted it to be, so I have 2 more quick examples for you. And these are the tricky ones right here. There's a graph. My arrows are the axes, and there's my line. It's a vertical line. It has a point of 2 and a point of -2. So I can't make my triangle. There's a rise, and the difference in the change in the y value is 4. The rise is 4, but there is no difference in the x value. No difference, 0. When I go to this line here, this is a horizontal line. I labeled 2 points. I know you can't read them on there, but this is -2, this is 2. So I'll count. You can count any points. I just chose those. I count those. The difference between those points is 4. That is the run. The rise, there's no rise. It's not going up and down at all. This line here is not going up and down, so the rise is 0. Every time you have a vertical line, when I count this, it doesn't matter what number I count, the rise will always be 0. I'm sorry, horizontal line. When I do this horizontal line, the rise is always going to be 0. That means the slope of a horizontal line is going to be 0. Every single time. It doesn't matter where the horizontal line is on the graph. For the vertical line, the 0 will always be the run, because there's no run. The 0 is always, the run is always 0. You cannot divide by 0. Division is how many groups of 0 are in 4. You can't do that. That is called undefined. So every slope of a vertical line is undefined. So that's the two exceptions to our rise over run. Vertical lines, undefined, because you're dividing by 0. There is no run. Horizontal lines are always 0, because the rise is 0 and the run is 0. So horizontal, 0, vertical, undefined. If you get confused, draw the lines and write the ratio, and you can remember that. There are plenty more examples around there. That's just my 2 cents worth right here. Thank you for listening. And number 3 is coming up later about the slope formula and finding from tables. Video card is the Jack of Spades.